Hello friends, welcome to our channel Mechanical Motivator. In this video, we're going to see multiple choice questions on dynamics of motion. Topic is Pickering Governor and sensitiveness and stability of the governor. So first one is the problem. So it's a centrifugal watt governor. Two balls will be having each mass of 2.5 kg and we need to find the height of the governor. So they have given the speed. So once they have given speed means omega is equal to 2 pi n by 60. So 2 into pi into n is 75 divided by 60 means you will be getting 7.85 radians per second. We know the height of the governor is equal to g divided by omega square. G is acceleration due to gravity and omega just now we found. So finally you will be getting 159 mm. Okay, the answer will be 0. You will be getting 0.159 meter. So if you convert into millimeter, 159 mm. So second problem, the same question and the same data. Here when data is missing, they have to give speed, then only we can calculate. So if they give the speed as n is equal to 75 rpm, so you'll be getting omega value, right? So 2 pi n by 60 means you'll be getting omega as 7.85, and you'll be getting the height of, you'll be getting the height of the governor as 159 mm. But in this case, they have clearly mentioned that the ball has risen 20 mm. So just imagine if the ball is rising means automatically we will be so in this question, they have clearly given that the ball is rising, right? So automatically the height of the governor will be reducing. So H1 will be 159 you got with the help of n 75 rpm. So H will be, height of the governor will be 159. In that 20 mm rises, right? So since it's rising means the height will be get reduced. So automatically H1 will be equal to 159 minus 20. So you'll be getting 139 mm, which is nothing but 0.139 meter. So now you can easily calculate the angular velocity. So just use the same formula. So height of the governor formula, H is equal to G omega square, right? So take omega to other side and bring the H downwards. So now you are having the H as 0.139 in terms of meter. So if you calculate mean, you will be getting 8.4 radian per second, I think so. You will be getting 8.4 radian per second. And once you got omega means it's easy for you to calculate speed. So we know the formula omega is equal to 2 pi n by 60. Now you have the value for omega. Omega value you have. Now you have to calculate for n alone. Just cross multiply, and if you calculate means you'll be getting 80.2 rpm. In next question, same thing, but only thing is the balls are fall. Since its balls rises mean height get reduced. If the ball fall means the height will get increased. So instead of subtracting, you have to plus. That is, here also data is missing. So speed will be 75 rpm. For that you will be getting a height of 159 mm. Since the ball is fallen means automatically there will be an increase in height. So automatically 159 plus 20 means you will be getting approximately you'll be getting 179 mm. So it's 0.179 meter, right? So same thing you have to do. So just calculate the omega. So height of the governor is G by omega square. So take omega to the other side, and if you calculate means you'll be getting 7.4 radian per second. And in terms, if you want to calculate speed means omega is equal to 2 pi n by 60. Omega value n value you have to calculate. So you'll be getting the value of 70.2 rpm. In next problem, actually this problem is a flywheel. Here we are having the mass as 200 kg and radius of gyration they have clearly given us 1 meter, and the torque value also they are given. So torque is 1200 Newton meter. We need to calculate angular acceleration of flywheel, so alpha, and angular speed omega for 10 seconds. So we know the formula for mass moment of inertia, I is equal to mk square. So if you calculate means you will be getting 2000 kg meter square. So torque is equal to I into alpha. I is moment of inertia, alpha is angular acceleration. So keep alpha to the left hand side. So if you keep alpha, formula is T is equal to I alpha, keep alpha alone. So bring that I downwards. So alpha is equal to T divided by I. T value 1200, I value 2000. If you calculate means you'll be getting 0.6 radian per second square. So now we have to calculate the angular velocity. So initially we will be considering the velocity will be 0. So omega is equal to omega naught, that will be 0 plus alpha into T. Alpha is, we just now calculated 0.6, time is 10 seconds. So you'll be getting 6 radian per second. Answer is 6 radian per second. So next thing, here the options, all the options, there is a small confusion. So don't consider the options. Now just give the idea alone. Mass moment of inertia for we need to calculate the mass moment of inertia. So we know very well. So mass moment of inertia formula is just a minute. So here they are asking us to calculate the two values, right? One will be mass moment of inertia and another one will be radius of gyration. So mass moment of inertia formula for solid sphere is I is equal to 2/5 of mr square. If you want to calculate the radius of gyration, means it's 3 divided by 5 into r square. 3 divided by 5 into r square. If you calculate, means you can get the values, but here the options are wrong. So next thing, we need to calculate the work done for punching. So this is a very important problem. So here they have given clearly that we need to calculate. You read the question, so I just explain the concept alone. So here we need to, first of all, we need to calculate force required to punch one hole. So that will be equal to area shared into ultimate shear strength. So area shared formula pi dt, and ultimate shear strength they are given the value 450 megapascal. So if we calculate, means you will be getting the value as 212.05 kilonewton. Next, we need to calculate the work done per minute, that is nothing but average force into thickness of the plate into number of holes per minute. So if you calculate, means you will be getting 10.69 kilonewton meter. So next thing, we need to calculate the when the weights move inwards and the spring bends. So actually this comes under Pickering Governor. Okay, so they haven't mentioned governor. Actually all these questions will be coming under Pickering Governor. So weight moves inwards and spring bends as they rotate. Actually it's false. For Pickering Governor, the weight will be moving outwards only. So next thing is we're going to deal with in case of Pickering Governor. So Pickering Governor, Hartnell Governor, and Proel or Porter or whichever even spring-loaded governors, all the governors will be working under the principle of centrifugal force. So the central load would be the centrifugal force. Answer would be centrifugal force. All these governors comes under the category of centrifugal force. So next thing is the Porter governor is used to vary the actually the Pickering Governor. Yeah. Pickering governor is used to vary the speed of the turntable and gramophone, and Porter governor is used to regulate the speed of the engine. So it's false. And next thing, which part of the spring, that is which the working, now we need to understand the working of Pickering governor. Actually the it includes the attachment of the lower end of the spring to the sleeve, which is free to slide on the spindle, and the spindle runs in the bearings at each end and is driven to gearing by a motor. So it's lower end only. And next thing is higher the lift, right? So we know very well, right? So just yeah. So for a given fraction of change of speed, so we know very well for an independent governor, the greater the lift of the sleeve will be corresponding to the change of speed, and in turn corresponds to greater in the stiffness. So the change of speed is directly proportional to the stiffness, directly proportional to the sleeve lift. So answer will be higher lift. So next one, we need to know for the given lift, right? So greater the lift of the sleeve will be corresponding to the fractional change of speed. So greater will be the stiffness of the governor. Just now we saw. So the statement is true. So next is a problem. Here we will be having a data. So we are having two different speed. Take N1 and N2. They are asking us to calculate the stiffness, sensitiveness of the governor. So mean speed is nothing but N1. Take minimum as N1 and maximum as N2. So N1 plus N2 will divide, mean speed means N1 plus N2 divided by 2. So you'll be getting 25 RPM, and difference of maximum and minimum speed. So difference of maximum is 30, minimum 20. So 30 minus 20, 10. So sensitiveness is ratio of difference of maximum and minimum speed divided by mean speed. So formula is sensitiveness is equal to ratio of difference in maximum and minimum speed divided by mean speed. If you calculate, you will be getting 0.4. And next is for a stable governor. So for a stable governor, if the equilibrium speed increases, the radius of governor balls must also increase. Automatically true, right? Once the speed increases, the radius increases. So next thing is, so just now we saw the definition. Here the ratio of difference of maximum and minimum to mean speed. So what is the definition for sensitiveness? Is ratio of difference of maximum and minimum speed to the mean speed. And next is a problem. Here we are having the sensitivity as 0.5. So we got here, right? So here we are having the sensitivity to be 0.5. So the given the value, mean speed they gave 20 RPM. We need to calculate the maximum speed. So mean speed is equal to N1 plus N2 divided by 2. equal to mean speed is 20. So you will be getting a form, I mean, you will be getting equation like n1 plus n2 is equal to 40. In second case, we know very well the sensitive ratio of maximum and minimum will be divided by the mean, right? So will be divided by the mean speed will be the sensitiveness. So maximum n1 minus n2 divided by 20 equal to 0.5. So 20 will be going to the other side, so you will be getting second equation, n1 minus n2 will be equal to 0.5 into 20. So first you got one equation, n1 plus n2 is equal to 40. Second you got one equation, so if you just solve these two equations, you will be getting the maximum speed as 25 rpm. So same method you have to do here also, and in first case you have found the maximum speed, in second case you will be finding the minimum speed. So same formula, only thing you need to understand is sensitivity is equal to maximum minus minimum divided by mean speed. Maximum is n1, minimum is n2, divided by mean speed is n. So if you want to calculate mean speed, means n is equal to n1 plus n2 divided by 2. So keep these formula and solve 15 and 16, you will be getting these answers. So next, on which factors the stability of the governor does not depend. Actually, stability depends upon speed, radius of rotation, governor equilibrium. Only thing is it does not depend upon mass of the engine. So when the governor is too sensitive, then which of the following occurs? So normally we know very well, right? Hunting is too sensitive. So we have saw this in many videos also, even in previous cases also we saw clearly. So answer will be hunting. Actually, hunting is a process in which the speed of the engine is continuously fluctuating above and below the mean speed. And this is sometimes something which happens when the governor is too sensitive. So it's too sensitive, it's hunting. And last one, when the speed of the governor increases, which of the following effect does friction effect? So normally we know, so when the sleeve when the speed increases, automatically the sleeve will be moving upwards, right? So automatically it prevents the downward movement of sleeve. So when speed increases, sleeve lift, so automatically sleeve won't be getting down, so it prevents the downward movement of sleeve. Please do subscribe to my channel Mechanical Motivator and press the bell icon, then only you will be getting all the videos which I upload. Thanks for watching this video. Have a great day.